Hello everyone. Today we are going to talk about a shortcut formula for finding out the hybridization in a given molecule or ion. In this formula, we should know first the number of valence electron on the central atom. You identify the central atom, and by knowing the central atom, first find out the number of valence electron on the central atom, and then number of monovalent atoms bonded to the central atom, and if it is an ion, then plus minus charge. Divide this by 2, we'll get the value of x, and if this x comes out to be 2, then the hybridization is sp. If it comes out to be 3, sp2, 4, sp3, and so on. We have to find out the value of x by knowing the valence electron on the central atom. For example, if I do an example for you, if I take BF3, Boron Trifluoride, and we know though boron is my central atom. Number of valence electron on this boron, which is the central atom, is 3 plus fluorine, which is the monovalent atom surrounded by it is 3. It comes out to be 6 divided by 2, that is equals to 3. It means the value of x equals to 3. And when the value of x is 3, what is the hybridization? sp2. It means BF3 has an sp2 hybridization, which we all know it is correct. Okay. Now we take one more example. If I take NO3 minus, the central atom is nitrogen having 5 electrons, and the surrounding atoms are oxygen, which are divalent, so we will not take any surrounding atom, we will take it 0. Plus the negative charge, we will add 1. Divided by 2, we will get the value of x. X comes out to be 5 plus 1, 6. 6 divided by 2, again 3. Thus for NO3 minus also, the hybridization is sp2. If I take another example, I3 minus, and now in this case I3 minus, the central atom is my iodine having 7 valence electrons, plus the 2 surrounding atoms are also iodine, plus 2, plus 1 negative charge. Total comes out to be 10. 10 divided by 2 equals to 5. The value of x is coming out to be 5. And for 5, the hybridization is sp3d. Thus, I3 minus is an hybridization sp3d. Same way, you can find out the hybridization in PF5. Phosphorus is the central atom having 5 valence electron. Surrounding atoms are monovalent 5. There is no charge, therefore x equals to half. 5 plus 5, that is equals to 5. Hybridization sp3d. Okay. ClO4 minus, the central atom is chlorine, which has 7 valence electron. Surrounding atoms are oxygen, which are divalent, therefore I will add only 0. And the negative charge is 1. When the charge is minus 1, then we'll add. What will be the answer? Answer will be half, x equals to half 7, which is the valence electron, plus 0, no monovalent atom, plus charge, which is 1. Negative is add up. X comes out to be 4, hybridization is sp3. Now if it's a positively charged ion, for example SF3 plus, sulfur has valence electron 6, 3 surrounding fluorine atom 3, and a positive charge, then X will be equals to half, 6 plus 3 minus 1, that is equals to 4, hybridization sp3. So by the help of this formula, you can find out hybridization any of the compound. Suppose you want to find out in CO2, C double bond O double bond O. Now, in case of CO2, the central atom is carbon. Carbon is a central atom having 4 valence electron. Oxygen are my surrounding atom, but they are divalent. I will take 0. It means 2 divided by 2. It means 4 divided by 2. 4 divided by 2, that comes out to be 2, and hybridization is sp. Hence the carbon atom in CO2, which the central atom is sp hybridized. So by the help of this formula, we can find out hybridization on central atom of any molecule, any ion. Okay, we take one more example, XCO3. Now xenon has 8 valence electrons, plus divalent atom is oxygen is divalent, therefore 0, no charge. 8 divided by 4, 2, that's equals to 4. Hybridization is sp3. It means xenon oxide has sp3 hybridization. One thing you should know or note here is, if the surrounding atom is a divalent, divalent are which? Divalent are oxygen and sulfur. Then you will not count them in the formula of X, you will take them as 0. But these should be surrounding, not the central atom. Got it? For example, in H2O and H2S, they are not surrounding, they are central atoms. We will count here If I want to find out the hybridization of H2O, now X equals to half, central atom is my oxygen. Oxygen is 6 valence electrons plus 2 hydrogen, total 8 divided by 2, that is 4. Hybridization is sp3. Similarly for H2 is also, the central atom is sulfur. X equals to half, 6 electron for sulfur plus 2 of hydrogen monovalent atoms gives you 8 divided by 2, that is equals to 4 again. What I mean to say here is, in this case, the oxygen and sulfur, they are not the surrounding atoms. Thus, we'll take them as central atoms and use their valence electron. But if the sulfur and oxygen, they are surrounding atoms, that is, they are divalent, we will not count them and we'll take their number as 0 in calculating the value of X. I hope this video will be useful to you to finding out the various hybridization of the given ions and compounds in your course, and that comes in your paper. Thank you very much for watching.